All right. So today's class, we're going to cover lesson 8.1, perpendicular bisectors of triangles. Today's learning goal is going to be I can construct the inscribed and circumscribed circles of a triangle. I can prove the properties of angles for the quadrilateral inscribed in a circle. Constructing the perpendicular bisectors. So as you can see right here, they actually show you an example of how to construct a perpendicular bisector to a segment. So you first start off with saying segment AB, then you would use a compass to draw your half circle without moving the radius. So your endpoint would be A. Hold on.
Hello.
How are you doing, sir?
Good. You?
Doing pretty good. We're going to review a couple lessons. We're going to give everybody a couple more minutes. I think people forgot because
Thanksgiving break?
yeah, basically uh, some students have Thanksgiving the whole week and other students don't. Like different schools depending on what school. For us it's only Thurs Thursday and Friday.
Wait, only for our school, what, Thursday and Friday?
Yeah. Yeah, a lot of students are telling me that they thought that there was not school this whole week, but on Friday or last week I told you guys on Wednesday I'm gonna give you guys the day off. Um, but what I'm gonna do is I'm gonna create the lessons, um, so that everybody could view them. So in this lesson, what we're gonna be learning is gonna be lesson 8.1, perpendicular bisectors of triangles. The learning goal is going to be you could construct inscribed and circumscribed circles of a triangle, and you could prove properties of angles or quadrilaterals inside a circle. So usually you would do this in class. You would construct a segment and you call it AB. And with a compass, you would create a half circle. So they guide you with the construction of a perpendicular bisector. So two things. Perpendicular means is going to create a right angle. Hey, Leo. Perpendicular means is going to create a right angle, and then bisector means it's going to cut the segment into two equal pieces.
We're gonna do all four of them?
We're going to try to do as much as we can. If we get through all four, then we'll do all four. If not, I'm going to create videos. Remember what I was telling you? So on Wednesday,
Yeah.
there's not going to be any class, but I'm going to create videos with kind of like if we did have class, and then you guys have to do them whenever you guys have a time. Next Monday, we're going to take a quiz. But I'm going to help you guys out with it because I know this credit is probably one of the longest ones. It has a lot of eight sections, I believe. That's double than the other credits. So it's really, really long. I don't know why they did it that way. So right now we're learning how to create a perpendicular bisector. So again, you would start off with the segment and you would take a compass and you would create two equal half circles, one that's centered at A and one that's centered at B. And the main thing that you're looking for is you're looking for these intersections. Then you would connect those intersections with the line, and it's going to give you a 90 degree. That's what perpendicular. That's what it means. It's going to give you a 90 degree, and then it's going to cut it in two equal pieces. So that means that from that intersection to B, it's the same distance than from A to the middle as well. So these are going to be two equal pieces. That's what perpendicular and then bisector means, two equal pieces. So that's kind of one thing that they show you there. And then on the next one, they're asking you what it means to be circumscribed. So that's just a triangle that has all the vertices touching the edge of a circle. So if you could see right here, notice that A, B, and C are touching the perimeter of the circle. And then you have a theorem for circumcenter. As you can see, if you find the circumcenter, you're going to notice that it cuts all the sides into bisectors. So the first page you actually have to do work is going to be page 40. So page 40, you're just going to take the paragraph proof that's on page 39, and we're going to lay it down in a two-column proof. So if you go back here, it says given lines L, M, and N are perpendicular bisectors of AB, AC, and BC. P is an intersection of line L, M, and N. So if you could look at number 1, it's exactly what the given is. So we're going to go ahead and write down given. And if we look at number 2, that's actually another given, right? Because it's also there. And then number 3 is saying PA. So it's saying this line right here is equal to PB. And we're going to use, we have our reason baked down here at the bottom. So PA is equal to PB. And that's going to be because P lies on the perpendicular. That symbol right there means perpendicular. Bisector of AB. The next one, PB, is equal to PC. So that means that one's also equal. And it's going to be the other one. P lies the only difference is that one lies on AB, the other one is on BC. And obviously the last one is the one that we didn't use, transitive property of equality. You could also notice it here. So notice that both of these are equal to PB. So then the other one, we could say that PA is equal to PC. That's what the transitive is. In here, they show you how to use that theorem in a couple math problems. So again, you don't have to really worry about the two-column proof because you're not going to get tested on that. But you are going to get tested on how to use the theorem. So they show you a couple of examples here. We're going to go straight to our problems, which is problem number 1 on page 41. So it says, given that ZG is 65, HL is 63, and ZL is 16, find CJ. So just by looking at the picture, what do you think CJ is? CJ is this one right here. So I'm going to put a question mark. Remember, we don't have to do any work from this. So look, if CG is 65, then the other side is they're congruent. That's what the theorem says. Even CH should be the exact same. So CJ would also be 65. So the next one, HJ. So what do you think I should do to find HJ? So remember, if this one is 63, what do you guys think this one is? the other side. If we go back to the triangle up above, right? These two are the same. These two are the same. These two are the same. So if you have a triangle that's that looks like this, I know that this is 63, that has to be 63. So then the whole thing, you would add them. So 63 plus 63 would be 126. Number 3, XA is 8. AB is 20, so that gives you this part. Find XC. All right, so one of you two, what do you think XC would be? Look at the other side. What do you think it's going to be? Could you guys hear me?
No, not really.
You can't hear me?
Oh, well, now I can.
So if AX is 8, what do you think XC would be?
20? Because it's like the same length between A and B.
Well, we just want a XZ. So AX is this part right here. That's 8. So what do you think XC would be?
Oh, you said X. I thought you said AC. My bad.
No. XC. That's going to be what?
10, right?
Oh, what's this one? All the middle ones are connected. So that's going to be 8. Guess what XB is going to be? They're all the same. So that's going to be 8 as well.
Oh, okay, I get you.
So all the middle ones, just like the top one, the GZ, it was 65. That's why this one's 65. And if
Yeah.
they were asking us for HZ, that would also be 65.
Okay. All right.
All right, so now it comes to BE. BE, it's half of this. So if the whole thing is 20, what's half? That's the one
10.
that's 10. Yeah. And this part is also 10. See, but I cannot say that this is also 20. I cannot do that. But if they were to give me that this is 30, then I could say that each part of these is 15.
Wait, so even if they like ask for what is AC and the A, like it matches up
We don't
with
know.
AB?
We don't know what AC is. We'd
Oh,
have to
okay.
use other properties to find what AC was, because we're not talking about an equilateral triangle. So this is not 20. That's why they have to give us that 20, and then we could say that the 2 halves is 10. That's the only thing we could say.
Okay, I get it.
But that's pretty much it. So that's it for the lesson. It's just that one thing for that triangle. These lessons are pretty small. So independent work, lesson 8.1. Which statement correctly describes the perpendicular bisector below? So in this case, what they're doing is they're constructing of TS to bisect QR. So these are kind of tough unless we go over how to actually build the constructions.
How do you know it's like how'd you figure it out? Like how'd you get that answer?
Because it's do you see that the line is red?
Yeah.
So we're constructing QX. So knowing that, what do you think number 2 is? What are they constructing there? Remember, they're going to construct, the red one is the one being constructed. So look, A says construction of GH. No, GH is the black one, that's given. GH is this one. So we're not constructing that one, we're constructing JK. So midpoint between point J and point K. Nope. Nope. We're constructing JK to bisect GH. And again, it takes more practice for constructions. And you only have 3 homework questions for this one. So this one, it's saying select 2 of the statements that are true. So the first one says XC is 10. Yes or no?
Yeah.
Yes. So go ahead and check that one. B is saying BX is 12. Is that true or false?
False.
False. It should be what? Do you know what it should be?
8, right?
No, it should be the same thing. All of these are the same.
Oh, EX?
BX. B and X should also be 10.
Oh, 10. Yeah.
Yeah.
I thought you said E.
Oh, sorry. C is saying AC is equal to 20. So this part over here is equal to 20. No, we don't know. We don't even know 1. Remember, for that one, we at least need to know 1, and then we could figure it out. So obviously, D, watch. D says BA is equal, so BA is this one. Is equal to 24. Well, this one, I do know that EB is 12, so this has to be 12 too. 12 plus 12 is 24. Therefore, D is also correct. BA is equal to 24. But remember what I was saying for that one, you at least need 1 number, and then you could find the rest of them for that side only, not for other sides. All right. So something similar. So only these 2 should be checked. Something similar to those is going to be this one. Let's see what they want in here. So when you're given a problem like this, what you want to do is just start off when you're reading it and start off writing down everything that they give you. So in this case, they say FZ is 36. So I'm going to put the 36 in FZ. ZA is 85. So I'm going to go here, and that's 85. And AB is 150. So that means this whole thing is 150. All right, so then I want to find out what AD is. What do you think? What is AD? What should I do? So remember, they give me 1 number for that side, so I should be able to find what each one of these are. Each of these are the same. So I have to divide the 150 by 2, and that would give me 75. So I know both of these are 75. What about the second one? What is ZB? So that's my new thing. So CB, what do you think it's going to be? So I'm going to let you guys enter that. What do you think CB should be? So just remember, guys, anything that goes to point Z are the same. So all three of these, right? It's going from the vertex to Z, from the vertex to Z. So all of these are the same. So I only have one number, so obviously all of these are going to be what? 85. But that's it. That's it for that one. So go ahead and go to. Right, that was a pretty fast lesson. It's just one theorem. The whole lesson is just
Yeah.
one theorem. So we're gonna go ahead and go to
So we don't have no like homework or credit checkpoint, whatever. We just turn it in.
we did the homework. So yeah, you just turned it in.
Oh, all right.
It was only 3 homework problems. We just did them all. So yeah, for that one, once you're done with it, just click turn in. So we're gonna go ahead and go to 8.2. Angle bisectors of triangles. So who could tell me what the definition of a bisector is? Definition of a bisector? Right? It's going to be to cut something into 2 congruent pieces, depending on what you're talking about. So in this case, lesson 8.2 is going to be an angle bisector of triangles. So I can construct an inscribed and circumscribed circles of a triangle. I can prove properties of angles for quadrilaterals inscribed in a circle. So the basics of this theorem, they are cutting just like the theorem says. It's you have an angle and they're putting a line right in the middle of that angle where it's going to cut it in half. So then this small angle is going to be the same thing as the other smaller angle. The whole theorem states that if you have a point C and you create perpendicular bisectors on either side, these two are going to be the same length, which is what this is. AC is going to be equal to BC. And again, they gave you a paragraph proof. And on the next page, what we're going to do is take that paragraph proof and we are going to make it into a 2-column proof. So given Vx is perpendicular to ray yx and segment VZ is perpendicular to ray YZ. So they actually give you 3 things. They tell you 2 are perpendicular, and then they tell you Vx is equal to Vz, and you have your little picture that they draw out there. So you could see the 90 degrees, that's where the perpendicular lies, so that's why we have 2. And you could see these little markings, it's what the second part is saying. So again, that's number 1 and that's number 2 given. So both of these would be given again. So we know that they're right angles. That's a definition of perpendicular lines. And again, that's the symbol for perpendicular. Oh, then we have, so look at the definitions down here at your recent bank. And do you remember what's the definition that or what should we use for number 4? It says YV is congruent to YV. So there's one particular definition in there that we could use. Do you guys remember? Reflexive property? And then we have two triangles are congruent. That's going to be because of the HL theorem. The next one after that is going to be this part right here. Corresponding parts of congruent triangles are congruent. We're going to shorten that up. Corresponding parts of congruent triangles are congruent. So you usually write CPCTC in all capitals whenever you have to write this down. And then your last one is going to be definition of angle bisector. So again, they're going to do this. They just want you to be able to go from a paragraph proof. All that you see here, it's going to be exactly.
Wait, can you go back up? Oh yeah, right there.
Yeah. And actually, this is the converse of the angle bisector theorem. I think the one they prove out here is the bisector theorem. So they are different then. And here they just show you how to use this proof. Basically, this proof is just telling you that this side is equal to the other side. You set them equal to each other. And then you do algebra 1 to find out what one side is. So you're going to end up with x is equal to 6, plug it back in, and then you end up with your LM is equal to 24. So you notice also these sides are the same, but also the angles are equal to each other, and that's what they did here. So again, it's not very difficult, the theorem. So according to this theorem, we know that SQ is equal to SR. So when I'm trying to do this problem, you can start off with the theorem tells me XQ is equal to SR. And then we just write down, we substitute. So SQ is 6x plus 2 equal to 8x minus 10. Then I'm going to subtract 6x to both sides. You end up with 2 is equal to 2x minus 10. And then add 10 to both sides. Bring down the 2x is equal to 12 and divide both sides by 2. You end up with x is equal to 6. Are we done? Well, the question is find SQ. SQ is here. Let me highlight that. SQ is here. So I found x. So I'm going to go ahead and find what SQ is by substituting. So SQ is equal to 6x plus 2, and then I have to substitute 6 in there. So that would be 36 plus 2, and that would give me SQ being 38. So again,
all you have to do is just solve for x first.
Yeah, solve for x and then plug it in. But the true thing is right here. The theorem lets us do this. The theorem that we're learning right now lets us make these two equal to each other. Same thing with number 2. Guess what we're going to do with these two? We're going to set them equal to each other the same way. So 14x minus 14 is equal to 12x. So I'm going to go ahead and subtract 12x to both sides. I end up with 0 on this side. And over here, I end up with 2x minus 14. I'm going to go ahead and add 14 to both sides.
Every time it's like that with the 12x being on the opposite side, you always take the 12x and subtract it on both sides.
I usually, whenever you have the same variable on both sides, you're going to move one to the other side of the equal sign. And usually that's done by subtracting, because I want to cancel it on this side. So I subtract it. But the reason is I always take the smallest to the biggest. That's why I moved to 12. Notice on number 1, right? I moved the 6. I subtracted the 6 first because 6 is smaller than the 8. That way I end up with a positive x instead of a negative. You could do it either way. You just have to make sure you're keeping track of your negatives. But if you always take not always, but most of the time, 90% of the time, if you take the smallest to the biggest, you're going to end up with a positive. So in this case, are we done? Did we figure it out?
No.
No, because you ended up with x, but they're not asking for x. They're asking for mjk. So in order to find that, I'm going to highlight it. I'm going to start off with m. So m, then I go to j, then I go to k. So we're looking for this. So I'm going to go ahead and plug it. That's mjk, and I'm going to plug 7 in here. Well, if I plug it, 7 times 14, that's going to give me 98. 98 minus 14, that would be 484. So angle MJK is going to be 84. And that's it. That's it for that lesson. They only give you a little. It's not that bad. So remember, the red are the ones that are being constructed. So if you look at number 1, what is being constructed on there? What is red? Well, it's going to be ZX, but all of them say ZX, so we can't cancel anything. We just know that it's going to be CX, the one that's being constructed. So parallel, do we have any parallel lines in here, right? It doesn't make any sense. We don't have any parallel lines here. Parallel lines are 2 lines that never meet, right? We didn't construct any of that. Do you see any perpendicular? Do you see any right angles on this one? No. What are we doing in this whole thing? We're doing angle bisectors. We're doing angle bisectors, not segment bisectors. So just by process of elimination, it's going to be C. Two is the same thing. So I'm going to let you guys think of number 2. If you guys want to continue doing the homework, you guys have to at least try it out, right? What is number 2? What do you guys think we're constructing on number 2? So to me, it looks like the red line is QT, so I'm constructing QT. So right away, it's either going to be A or D. It's going to be one of those two. That's it. We're constructing something that bisects an angle. So is it A or D? Which one says that it's bisecting an angle? Right, just from reading it, which one, A or D, which one says that you're bisecting an angle? Are you guys there? Leah or Then, which one, A or D, which one says that you're bisecting an angle from just reading them? Well, I hope you guys see that, D says construction of QT to bisect angle SQR. So this whole section is about bisecting angles. Number 3. Hopefully you guys understand we're going to be using the theorem. The theorem states that those two are equal to each other. And then we just solve for x. So remember it says x is equal to 3, but that's what we want. It says x, so there's nothing more to do. X is equal to 3. All right, we're going to move on to the next one. Same thing, you want to find BC. So in this case, we're not finding y, we're finding BC. So we have to find y first and then plug it in. So we should know by the theorem, BC is equal to BD. So then we just substitute. And I'm going to go ahead and subtract 4y to both sides. You end up with 2y minus 16 is equal to 6. Add 16 to both sides. 2y is equal to 22. And then divide both sides by 2. And you end up with y is equal to 11. Always remember, they're not looking for y, they're looking for BC. So BC, I'm going to write down the expression that BC is equal to, and then I'm going to substitute the 11 on there. 6 times 11 would give me 66. 66 minus 16 would give me 50. So then BC would equal to 50. Number 2, I'm going to set it up. All you're doing, the geometry part, is making those equal to each other. Again, I like to, when I'm doing these equations, I like to put the one that has the bigger x value first, and then set it equal to the one that has the smaller x value. Subtract the 3x to both sides, and then finish it off. You are going to end up with x is equal to something. And then you have to plug it in. So AD is equal to 15x minus 22. And then you have to plug in what x is so that you could figure out what AD is. So that's going to be your guys' job to finish off number 2. Sound good? Hey, are you guys there? Oh, that and Leo?
Yeah.
Okay. I'm gonna give you guys, let me know when you're done with that so that I could.
I'm done.
You're done? What about you, Adon?
What was that?
Are you done with number 2?
Yeah.
All right, so let's move on to the next section, which is 8.3. Like I said, most of these pretty easy, only 2 or 3 pages per set. There's only one theorem on each one of these lessons. That's why we could probably finish all 4. We will see. All right, so this is going to be the centroid theorem. So lesson 8.3, medians and altitudes of triangles. Now notice from the picture what a median is. The median goes from a vertex. So in this case, this median is going from a vertex and it goes down to the opposite side and it cuts it, it bisects that side. So this median is bisecting AC, so these 2 sides are equal. So that's what medians do. And guess what? They cut a triangle and they found all 3 medians. And then you could notice a couple of things that are happening when you do that. So it says the centroid theorem states that the centroid of a triangle is located 2/3 of the distance from the vertex of each opposite side. So 2/3. So what they're saying is that G is the centroid. So AG is 2/3 of the whole segment AF. So remember, this would be 2/3 of the whole segment AF, and the other one would be what's left, which is 1/3 of AF. And that's how they're getting all these formulas. They're either going to be 2/3 or 1/3. The biggest piece is 2/3 long of the whole segment, and the smaller piece is 1/3 long of the whole segment. They give you an example in here. So look, MN is 2.5. Find IN. So in here, they're using the theorems that they have here at the bottom. So what that's saying is that the long side is if you know that you have a centroid, it's double of the smaller side. So if you multiply 2.5 times 2, that's going to give you this side right here. So that's why that's 5. Now, thinking about that, let's see if we have another question, find ln. That's going to be half of the other side. So remember, we're always looking at the same segment. So have a 6, that would be 3. So again, if they give you one of the small ones, you're either going to be multiplying by 2/3, 1/3, or you're going to be multiplying it by 2 or dividing it by 2. So they give you a couple more examples here. Oh, that's the one. Hn is 6. Find NL. Look at what NL is. That's that whole length. Well, look at the top, right? I already found that that was 3 because it's half of that 6. They use a different format here to figure it out, right? But I'm not going to use that formula. I know that it's 3 because it's half of it. So if I add those two, 6 plus 3 would be 9. And I don't have to do all the work that they just did because I used the theorem. They didn't use it. Well, they kind of used the theorem, but they used the wrong portions of the theorem. And they made it really, really hard. Same thing for number 3, right? Number 3, look. They already know that this is 2.5. We already know that that's 5 by number 1. And if we add both of them, 7.5. So you could skip all this work just by using the formula a little bit different than they are. So let's see if we could use this formula on number 1. It says BH is 18. All right, so if this is 18, what do you guys think the other little small side is? HE. Remember, guys, it's just half of it. So what's half of 18? 9. Just by using the theorem, that's 9. Now look at number 2. It says BH is 18. Find BE. Add both of them together. BE is the whole line. So add 18 plus 9, that's going to be 27. All right, number 4 or number 3, CH is 4. So knowing that, what do you think FH would be? If CH is 4, if CH is 4, what do you think FH would be? So remember, with this formula, it's either double or it's half. So do you think FH would be half or double? So I'm talking about
More
the
than
segment.
half. It'd be more than half, right?
No. According to the theorem, it has to be either half, and that's what is important. The theorem is saying if this is 4, the bigger side is double that, so that has to be 8. Right? But they don't want that part. I only found it because that's going to help me find CF. So if I add both of those, 8 plus the 4, that's going to give me 12. And that's what CF is. Number 4, they gave it to you, but then they asked you to do number 5. Number 5 says BG. So they have 2 lines like that, and BG is halfway. So B, G, and F. And they tell you that this side is 11. But guess what? This side is also 11. You could see the little tick marks that are here. That means that they're congruent. So together, to find BF, you have to add BG plus GF, which would give me 22. So notice that if you have a triangle with the centroid, the outsides are the same. So if whatever this part is, it's the same thing as the other part. FE is equal to F or ED, and BC is equal to CD. And then the middle parts, they're either going to be half or doubled. That's why if I know that this part is 4, I know that the other part is 8. If this part is 9, then the other part is 18. So look at, let's go to page 52. And look at this one. It says, number 1 says, in the figure below, PU is equal to 12. I'm going to go ahead and write it down. VT is equal to 5. And VQ is equal to 6. So we want something that is false. So is RU 12 as well? Is that true or false? This is true. If PU is 12, remember RU is the same thing, so that would be 12 as well. UV is 3. So UV is inside here, and they're saying that that's 3. Well, I know that that's half of this part, and that should be 3, so that's true. The other one is saying PR is 17. PR is this whole thing. So it's 12 plus 12, and that's 24. I think I found the false one, right? It's saying that it's 17, which is false. Same thing for number 2. You're just trying to find out which one is false. So I'm going to go ahead and write them down. FE is 8. EH is 8. HD is 18. This one is saying, number 1 is saying FD is equal to BE. FD is equal to BE. We don't know. There's no way of us telling. It could be equal, but we don't know yet. So I'm not gonna write anything down. I'm gonna check the other ones. BH is equal to FD. We do know that part. BH is equal to F. Actually, that part, I don't know if there's a theorem that allows us to say that BH is equal to FD. EH is equal to let's see, if this is 18, then this would be double, so that would be 16. A plus 16 would be 24. So that one is correct. So I know for sure it's not going to be that one because we're trying to look for something that's false. The other ones, we would have to do a little bit more math to actually figure it out. So I'm going to go ahead and start doing some of the math. I know if this is 18, this one should be 9. If this is 8, that's 8 as well. So now let's start going back. I'm looking at C. It says EH. So that's 8 is equal to ED, which is also 8. So that one is true. I see what they're doing. They want you to fill out the whole triangle with all the numbers to see if they're true or not. So BH is equal to FD. BH is 16, and FD is 8 plus 8, which is also 16. So that's true as well. So the only one that we're not going to be able to solve is going to be A. We don't know, well, FD. Let me see. FD is 16, and it's equal to BE. Oh, BE is 24. So we know that that's false. Yeah, so the only way to figure out number 2 is to actually start filling out the numbers. Remember, they're pretty basic. This theorem just says the smallest side is half of the other side. That's why if that's 9, the other one's 18, and vice versa. So if this one's 8, the other side is double, so 8 times 2 is 16. All right, so let's go ahead and try to see if we could figure these out. This is page 53. So they already gave you all the numbers, and they're asking for the first one. For A, it says Ly. So Ly, this is L, and this is Y. So by the way, this 12 is this whole side. That's what the 12 means. So if I'm trying to find just this part, what do you think it should be? If the whole thing is 12, guys, remember, each one is the same. So you just have to divide it by 2 so that you can get 2 equal parts.
6.
6. For part B, you're trying to find KY. So you're trying to find this whole thing right here. Now look, this little part right here is 1.8. I multiply it by 2 so I could find this other part on top. So 1.8 times 2 would give me 3.6. To find KY, I have to add those two. KY is the whole length, the whole segment. So that's going to be 3.6 plus 1.8, and that's going to be 5.4. We're going to do something similar to find the last one. The last one is saying find ZJ. So I'm trying to find, okay. CJ is the one that goes from the vertex Z all the way to this side. So notice, they tell me that the long side is 8.2. So the little side is going to be half of that. Half of 8.2 is 4.1. And then to find ZJ, I have to add those two. 4.1 plus 8.2. If you add those two, it would give you 12.3. So CJ is 12.3. Hopefully that makes sense. Again, for the inside, you're just dividing by 2 or multiplying by 2 to figure out from the small side to the big side. And all the outsides, when you have a triangle like this with the centroid, all the lengths are cut into equal pieces.
Can you go back up to question 4 on the your turn?
Question 4 is done for you. You don't have to write anything.
Oh, question 5. My bad. I didn't see that. Yeah. All right, I'm done.
All right, so let's go ahead and go to 18.4 or 8.4, lesson 8.4. I hate that it keeps asking me to do that. All right, so we're going to do 8.4. And 8.4 is very, very similar. So in lesson 8.4, we're going to learn mid-segment of triangles. The lesson goal: I can prove the following theorems about triangles. The segment joining midpoints of two sides of the triangle is parallel to the third side and half its length. So what this theorem is saying, the triangle mid-segment theorem, it's saying that if x and y are midpoints of each of their segments respectively, so basically x is the middle of AC and y is the middle of CB, then xy is parallel to AB. So these two lines are parallel, xy and AB are parallel. Not only that, xy is half of the length of AB. So I repeat it, xy is half of AB. And that's your theorem. Reverse, AB is double the length of xy. So again, either multiplying by 2 or dividing by 2. So this is saying basically if this is 10, the middle one is 5. It's half of it. Now, if they tell you that the middle one is 10, what would the big one be? If they tell you that this is 10, what would the bottom one be? Double. So what's double of 10? Double of 10 is 20. They show you of a couple of examples here. Look, 4.6, 4.6. You're going to use it to find the outside one. You're going to have to double it. So 4.6 times 2, 9.2. That's how they got that the top one is 9.2. In here, for number 1, they're saying find JLK. So J, L, and K. So this angle is going to be the same thing as that angle. So what do you think it's going to be? It's going to be 105. And then JL. So when you're looking at this, JL is going to be double of 39. So 78. Let's go ahead and go to page 56. This is where it starts getting it's a little bit more complicated because in this case we're going to have to find out equations, solve for the variable, and then plug back in. So we have to use the theorem. It says find BW. So I know that if I multiply the bottom one, if I multiply the middle one by 2, so 2 times 4y plus 7, that's equal to the bottom one, which is 12y minus 14. So notice I'm multiplying that small one to make it equal. That's my theorem. Multiply the small one and set it equal to the big one. And then I have to distribute the 2. I get 8y plus 14 is equal to 12y minus 14. I'm going to go ahead and subtract 8y to both sides. You end up with 14 is equal to 4y minus 14. Add 14 to both sides. You end up with 4y is equal to 28, and then divide both sides by 4. You end up with y is equal to 7. But remember, we're not looking for y, we're looking for VW. So VW is equal to 4y plus 7. And substitute what we got for y, which was 7. So that's going to be 28 plus 7. And 28 plus 7 is 35. So VW is equal to 35. So you're going to do the same thing for number 4. It says find y, z. So let me change color. Now they're talking about these two lines. But we're going to set up the equation the same. So I know if I multiply the small line, which is 7x minus 17, that's equal to the big line, which is 8x plus 2. And I know that I'm going to have to plug in whatever I get for x. I'm going to have to plug in for yz, which is 8x plus 2. Again, distribute the 2. 14x minus 34 is equal to 8x plus 2. Since we have x's on both sides of the equation, I'm going to go ahead and subtract 8x to both sides. You end up with 6x minus 34 is equal to positive 2. Add 34 to both sides. 6x is equal to 36, and divide both sides by 6. You end up with x is equal to 6. And then you're going to substitute into your yz. 8 times 6 would be 48. 48 plus 2 would give you 50. So now I know that yz is 50. A lot of algebra in these. These are, the formulas are not that hard, or the theorems are not that hard, but finding the x and then plugging it back in, there's just a lot of room for error, a lot of algebra in these problems. So in here, we're just gonna write these down. This one is saying DE is parallel to, what's the side that it's parallel to? DE. What's the other segment? It's the bottom one. B, C. And if you multiply the E by 2, that's the theorem right there. If you multiply the middle one by 2, that's going to give you the bottom one as well, BC. So number 2, they flip it. I'm going to let you guys work on number 2. They flipped it, but you should be able to, it's the same thing as number 1. Number 3 is saying find the measurement of ED. So watch, if HJ is 14, what do you think ED would be? So that's what we're trying to find. What do you think ED is? They gave you the bottom one, it's 14. Do you think ED is more or less than 14? Are you guys, Leo, are you there?
Yeah.
Do you think ED is more or less than 14?
ED?
Yeah.
Oh, we're on question 3. Oh, you said it. Okay. Less.
It is going to be less. How much less? Do you have an idea of what it could be?
You said it has to be half of 14, right?
There you go. Yeah. Half of 14 is 7. What about number 4? They tell you the middle one, 8. What do you think I should do to find an L, the outside one?
More.
So instead of half, what should I do?
Add it. Add
Or
like
double it.
yeah, double it. There you go. There you go.
Yeah. So 8 times 2 would give me 16.
Yeah.
So number 2, the one you circled, that's the one we do.
All right, sorry about that. All right, so number 5, it's saying just find x, so that's good. So I know that if I multiply the middle one, which
So
is
for number
x,
2, the one you circled, is that the one we do like on like independent?
yeah.
All right, I was just making sure.
Yeah, I was saying that number 2 is very similar to number 1, so you guys were gonna do that. Just like number 5 and number 6 are very similar. I'm gonna do number 5, and then you guys are gonna do number 6. So number 5, the middle one, I know if I multiply by 2, it's equal to the large one, which is at the bottom, which is just x. So then I'm gonna go ahead and distribute the 2. You end up with 2x minus 12 is equal to x. And then I'm going to go ahead and subtract x to both sides. I'm going to end up with x minus 12 is equal to 0. And then I'm going to add 12 to both sides. So you end up with x is equal to 12. And that's what we want. We just want x. So number 6, same thing. All you want is x, but let's set it up. So I know if I multiply the middle by 2, that's equal to the outside one, x plus 14. Distribute and then get the x by itself. After you do the algebra, that's going to be on you guys. And then figure number 6 out. In this last one, or in page 58, right, we're talking about these two lines. Remember, it's always the same for that theorem. As long as it's in the middle, I know that if I multiply that middle one by 2, it's equal to the outside one. So then I'm going to go ahead and distribute that 2. So you get 2x minus 6. And then you just do the algebra, subtract x to both sides. And then add a 6 to both sides. You end up with x is equal to 9, and that's your first part. Now I need that 9 to find QP. I knew that QP, according to my diagram, it's x minus 3. And I'm going to go ahead and substitute x for what I got earlier. So 9 minus 3, that's going to give you 6. So QP is 6. So for this last one, we're going to do, let's set up the equation first. So I know if I multiply PQ by what? What have I been multiplying all the middle ones by? According to the theorem, multiply by, right? Look at the number up here in the front, on top. You multiply the middle by 2. And you set it equal to the outside one. 3x minus 3. And then I'm going to go ahead and substitute, or not substitute, distribute that 2. 2x plus 4 is equal to 3x minus 3. Now remember, I always like to go from the small one to the big one. That's why I subtracted the 2x this time to the other side. And then you add the 3. You end up with 1x is equal to 7. 1x and x is the same thing. You don't need to do anything with the 1. And then it's your job to find xv. So just remember xv is this one up here. So substitute x into xv and then figure out what it is after you substitute x in there. And that's pretty much it. If you guys come in Wednesday, we'll you guys don't have to. After these 3 lessons, whatever's left is the quiz. I'm gonna be doing the quiz. I'm gonna be recording it as well on Wednesday. I'm not gonna be doing the whole thing. Like I said, for the quiz, it's just gonna be a combination of, you know what? Don't even worry about it. We'll talk about it next Monday. We'll do the quiz next Monday, and then you guys are done with credit 4.
So what's happening Wednesday?
No class. You guys are free to enjoy your Thanksgiving weekend after today. Make sure to finish these last 3 lessons that we just did.
Okay.
Actually, 4 lessons.
Hey.
All right. So finish the 4 lessons we did today. Submit them. I'll grade them. Wednesday, you guys have the day off. Monday, we're gonna be talking about the quiz as a class. Sound good?
Yeah.
All right, and then we're done for today. So you guys are free to leave.
All right. Thank you. Have a good day.
All right, you too.